U.S. firm builds a 360-degree rotating turret to kill drone swarms. A U.S. defense startup is bringing a next-generation counter-drone system to SLEF Week 2026 in Tampa that takes a fundamentally different approach to the close-in drone threat. Instead of aiming at incoming targets, it keeps multiple barrels constantly rotating through a full hemisphere, eliminating the aiming delay that makes conventional single-barrel systems vulnerable to fast-moving drones and swarms. Picket Defense Systems announced it will display the Inferno RDC, its newest counter-drone platform, at SLEF Week running May 18-21 at the Tampa Convention Center. The system is built around a patented rotating turret design that mounts multiple munition barrels at fixed elevation angles on a spherical frame, sweeping a complete 360-degree hemisphere continuously as the turret rotates. When onboard sensors detect and classify a threat, the system selects the optimal barrel and fires without any slito-target delay, per the company's product documentation. Picket describes the result as a 40-meter assured kill zone in every direction with zero aiming latency. The aiming latency problem the Inferno is designed to solve is one of the most technically challenging aspects of close-in drone defense, and it has become increasingly urgent as adversaries have adopted tactics specifically designed to exploit it. Conventional counter-drone gun systems, whether mounted on vehicles or fixed at a site, must physically slew a barrel to point at an incoming threat before firing, a process that takes measurable time, even on fast-actuating electromechanical systems. Against a single drone approaching at moderate speed, that delay is manageable. Against a coordinated swarm of fast-moving targets approaching from multiple directions simultaneously, it creates engagement sequencing problems that single-barrel systems have no mechanical solution for. The Inferno's continuously rotating architecture eliminates that sequencing problem by having a barrel already in approximately the right position for any threat vector at any moment. The system comes in two configurations according to Picket's specifications. The small variant weighs 45 pounds, measures 18 inches in diameter, carries 36 barrels, and fires 556 millimeters, 410 or 20 gauge munitions. The large variant weighs 90 pounds, measures 24 by 30 inches, carries 54 barrels, and scales up to 12 gauge through 40 millimeters. Low-velocity rounds. Both variants cover a full 360-degree hemisphere, both detect threats passively at 90 to 120 meters, and both use 3D-printed resin construction that keeps weight and cost below what traditional machined metal components would require. The choice of materials is notable. 3D-printed resin turrets are considerably cheaper and faster to produce than machined aluminum or steel equivalents, which matters for a platform that might be consumed in high-attrition counter-drone operations. Detection is handled by a non-emitting sensor architecture that Picket describes as a fusion of a 3D acoustic microphone array and camera systems, producing passive threat detection with zero radar signature and no electronic emissions that adversaries can detect. Jam or home on the acoustic detection approach has precedent in counter-drone development. Drones produce distinctive acoustic signatures that differ by size, rotor configuration, and flight profile, and acoustic arrays have been used in fixed-site detection systems for several years. Combining acoustic detection with camera-based visual classification and onboard AI running what Picket calls tiny ML classifiers allows the system to identify and prioritize threats in real time without communicating with external networks, maintaining its stealth signature throughout an engagement. The effector suite extends beyond kinetic rounds to include nets, dazzlers, and obscurants, all integrated into the same rotating turret platform. According to Picket's system overview, that multi-domain capability matters for environments where kinetic engagement is legally or operationally restricted, including civilian infrastructure protection, border security, and certain force protection scenarios where collateral damage from live munitions is unacceptable, offering less lethal effector options. Within the same hardware platform that provides kinetic engagement gives operators flexibility to match the response to the legal and operational context without switching between separate systems. SLEF Week is the annual gathering of the U.S. Special Operations community in Tampa, drawing operators, acquisition officials, and defense industry representatives from across the American and allied special operations enterprise. It is a venue where counter-drone technology has attracted growing attention as special operations forces have encountered drone threats in virtually every operational environment they work in, from the Sahel to the Middle East to the Indo-Pacific. A system as compact and Manpack Portable as the small Inferno variant, which at 45 pounds falls within the load that a dismounted team can carry and deploy, rapidly addresses a specific gap that larger vehicle-mounted or fixed-site counter-drone systems cannot fill. The Inferno's claimed capabilities include engagement of fiber-optic guided drones, which represent one of the hardest counter-drone problems because they cannot be jammed electronically since they receive guidance through a physical wire rather than radio frequency commands. Against a fiber-optic drone, electronic warfare is useless, and kinetic engagement is the only reliable defeat mechanism. A system that can engage kinetically in any direction without aiming delay has a theoretical advantage against that threat category that conventional systems lack, though Picket has not specified test data supporting that particular claim.